Well, hello everyone, and good afternoon, East Coast. Good morning, everywhere else. Okay, so my name is Audrey from ACG Math Tutoring, and what do? I come here live. I'm thinking of every Tuesday. I want to say 1 o'clock, even though I'm a little bit late. But I always try to give a concept that a lot of my tutoring sessions was going through. So today I had a student that was going through trig functions, and they were using 1 point to identify those trig functions so we can get those SOHCAHTOA ratios. So what I'm actually going to be looking at is something that's going to help with those step-by-step inclines. So let's take a look. We have a point, 4, -3. Okay, we have our coordinate planes, our x-axis and our y-axis. And we want to find the cosine, the sine, and the tangent. And we need to look at it based on the graph. Well, first thing, we need to take a look at the point. And we need to figure out which of the 4 quadrants, is it quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Where is this point 4, -3 is going to end up at? Well, since my x-axis, my x's is 4, my y is -3. In quadrant 1, all the points positive, positive. So that means my x and my y's are both positive. In the second quadrant, we have negative, positive. So that means my x-axis, they're dealing with negative numbers. My y-axis is dealing with positive numbers. In the third quadrant, it's negative, negative. It looks like a face, right? My x-axis is negative and my y-axis is negative. And in the fourth quadrant, we have positive, negative. My x-axis is positive and my y-axis is negative. That's roughly where we're going to find our point in that fourth quadrant. So starting here at the origin, anytime we're plotting points, that's where you start. So I'm going to go to the right 4, so that'll be roughly here. And then I'm going to go down 3, which is going to be roughly around here somewhere. So by identifying your quadrant, we know that if I drew a line from my origin to that point, that, based on trig, this will be my hypotenuse. Because if I draw out, I'm going to have a right triangle, and the angle that is formed with the vertex, formed with the origin, that's going to be my theta. Okay, so theta. Okay, so it's a Greek symbol looking at that angle measure. So right now, we're not looking at so much the angle. So the reason why I know this point is here, because my x-axis is positive and my y-axis is negative. This is also not only giving us the point, but it's also giving us the length of our 2 legs. So from the origin to this section is going to be a positive 4, because that's where my x is. And my y's from this section to here will be a -3, because I went down 3. So with this information, we just need to figure out what is the length of my hypotenuse. So what we could do is use Pythagorean's theorem. Okay, we got a right triangle. We got 2 legs. All we need is to find our hypotenuse. So if I slide over here, remember Pythagorean theorem is your a squared plus your b squared equals your c squared. All right, so your the a and the b are interchangeable. But I'm going to put -3 squared. I don't know why I said cube. Plus 4 squared equals my unknown squared. So now, -3 squared, that's going to give me a positive 9 because a negative times a negative gives me positive. Plus my 4 squared, that gives me 16. And that's going to equal my x squared. So 9 plus 16, that gives me 25. So if x squared equals 25, I want to know what my x is, not what the x squared is. So the opposite of a square is a square root, not a circle. All right? Squares and square roots, they're inverses of each other. So they're going to cancel out. But now I got the square root of 25. And a lot of people are probably shouting, oh, the answer is 5 because it's a 3, 4, 5 triangle. But here's the thing. When it's coming out of a squared situation, you usually are supposed to get 2 solutions. It should be plus minus 5. But does this make sense? No, because if we're trying to find the length of the hypotenuse, my length of the hypotenuse is not going to be negative. It's going to be positive. Okay, so that means we're dealing with a positive 5 for my unknown hypotenuse. So I'm going to put my positive 5 here. Now, we need to go with the SOHCAHTOA. All right, so with the CA, that's going to be your cosine of theta, which is your adjacent side over hypotenuse. Your sine of theta is going to be your opposite over hypotenuse. And then your tangent of theta is going to be your opposite over your adjacent. Okay? And it's all derived by the angle of theta. Okay? So from here, if I wanted to go opposite, that means the side that's directly across from my theta is my opposite. The side that's directly across from that 90-degree angle, that's my hypotenuse. That's going to be my longest side. So that means what's left over is your adjacent side. And a lot of people are like, I don't know which one's my adjacent, which one's opposite. Well, you know, opposite means across from. Okay, so once you know where your theta is, you can go across from that. That's opposite. Then wherever you would think your 90-degree or your longest side is going to be, that's your hypotenuse. And then what's left over would be your adjacent side. So now we're going to use this information. Okay, we already have it labeled for us to kind of fill in. So for the cosine of theta, cosine is your adjacent over your hypotenuse. Your adjacent is 4, and your hypotenuse is 5. Okay, so the ratio that's associated with your cosine of theta is 4/5. For now the sine is your opposite over hypotenuse. Opposite is -3. Hypotenuse is 5. Okay, so the ratio for the sine of theta is going to be -3/5. And now for your tangent is going to be your opposite over the adjacent. And if you want, you can basically take the numerators of the sine and the cosine to help you out. So opposite is going to be -3, and adjacent is going to be 4. Okay, so this is how you're going to figure out your ratios when they give you a point. Okay, so let's take a look at another one. And if you have any questions, do not hesitate. Go ahead, put it into the chat. So this time we have 6, 8, 6, 8. So remember, you have your quadrant 1, your quadrant 2, your quadrant 3, and your quadrant 4. Where is 6, 8 going to be located? So hopefully you're saying somewhere around here. Drawing my line or my segment from the origin to that point. 6 is positive, 8 is positive. So you need to put that place where it's a positive section, which is in your Q1, quadrant 1. So seeing how my line is and where my point is, I'm going to construct a triangle. Not only a triangle, but a right triangle. Your theta is always going to be right where your vertex is at the origin. This is always going to be your theta. Okay? It's easy to keep track of that. So now, if I want to know the length of my x, I go to my x value of the coordinate, which is 6. If I want to find the length of my y, I go to the y coordinate, which is 8. So now we're looking for, the hypotenuse again. So since we're looking for the hypotenuse, let's slide this over. So again, we have our a squared plus b squared equals c squared. And there's going to be pieces missing, but we just got to fill it in. Remember, your two legs are interchangeable. So it doesn't matter which one's A and which one's B. All right? So I'm going to say 6 squared plus 8 squared equals my x squared, or c squared. All right? So 6 squared gives us 36. 8 squared gives us 64. And we're going to add that up so we can get our next part. So that should be 100. The way my life is set up, I better say, double check it. I'm not going to sit here and lie and say that I'm a perfectionist. No, I'm not. I may be an expertise in my area, but I am not a robot. Okay? So now we got our 100. But that's what x squared is equal. So we need to figure out what x is going to equal. In order to do that, I have to take the square root of both sides of the equal sign. Remember, squares and square roots, they cancel each other out. So now I have the square root of 100, which a lot of people are probably shouting 10, because 10 times 10 gives me that 100. And then it's going to equal our x. But you're probably saying, well, Miss Audrey, what about that plus minus? Remember, if we're looking at a length, we're not looking at the negative. We're looking at the positive. All right? So now that means our radius, basically, is 10. But we need to figure out our cosine, our sine, and our theta, all based on that symbol. So cosine, I'm going to bring it down here again. See if I can get us somewhat centered. So we have our cosine, that's your adjacent over your hypotenuse. We have your sine, which is opposite. I don't know why I put parentheses all of a sudden. Over your hypotenuse. And then you have your tangent. And then your tangent is your opposite. Again, I don't know why I'm doing parentheses. Over adjacent. I guess I want you to really see what's supposed to go inside. So for us to get the cosine of theta, here's my theta. I need to start labeling. Start labeling before you start tackling these things. So opposite means opposite my angle. Okay. So now the side that's directly across from that 90-degree angle, that's your hypotenuse. So that means 6 is going to be my adjacent side. So cosine is your adjacent over your hypotenuse. My adjacent is 6. I'll put it up here. And my hypotenuse is 10. But 6/10, although we are great-minded people, 6/10 can be reduced. So if I reduce it by 2, you're going to have 4 over 4. Where am I getting 4 from? Woo! You can tell I'm tired. 3 over 5. Okay? So it's 3 over 5. Now, for the sine, it's going to be our opposite. So it's 8 over 10. That can be reduced as well by 2. Let's see if I can get it right this time. 4 over 5. Okay? And our tangent is our opposite, which is 8, over our adjacent, which is 6. If you reduce those by 2, okay, you will get your 4 over 3. Okay? When both the numerator and denominator are even numbers, I know they are somewhat either divisible by 2 or the parents of 2, like 2, 4, 6, 8, 10, something like that. It's definitely divisible by an even number. All right? So for our COA, we have 3/5. For our SOCA, we have 4/5. And for our TOA, we have 4/3. So SOCA, TOA. All right. Okay. Let's try one more and then we're done. That's it. Okay. Because I'm not going to keep beating the dead horse. It's dead. Let it lie. Why are we torturing that poor animal? Just let it go. All right. So, first thing, what quadrant is this going to be in? -8/15. What quadrant? What quadrant? Okay. Second quadrant. Good. So, -8/15, somewhere all the way up here. All right. So that means I'm drawing from this point to my origin. And then I'm creating or constructing a right triangle. So my x values is -8. My y values is a +15. And we need to find out that hypotenuse. Only way to do it, Pythagorean theorem. So we have our a squared plus our b squared equals our c squared. So the legs are interchangeable. I know some of you guys don't believe me, so I'm going to do 15 squared plus -8 squared equals our x squared. So with our 15 squared plus our -8 squared, which gives me 64, we'll have 225 plus 64. That's equal our x squared. So 225 and 64. Why am I not writing stuff down? So crazy. This is why we don't do math in pen. See? Exhibit A. All right, so we'll add that together so we get our 289. But that's what x squared equals. So in order for us to get rid of that square, we have to do the square root. So let me just put devil's advocate. If it was a cube, then you would have to do the cube root. Okay? So the square root of 289, that is a perfect square root, which gives me 17. So x, because they cancel, will equal 17. So that means here's your hypotenuse at 17. So again, your theta is always near your origin. So here is our theta. Okay. So that means the side directly across from our theta, this is going to be opposite. The side that's directly across our 90-degree angle, okay, that's your hypotenuse. So that means it's -8 has to be your agenda. Excuse me. Oh, that hurt. All right. So, SOHCAHTOA. So I know sine, cosine, tangent. Okay. SOHCAHTOA. All right. So we want to go with our adjacent over our hypotenuse. So adjacent, -8. Hypotenuse, 17. You have an even number and an odd number, cannot be reduced. Okay, your sine. So that's your opposite, which is 15, over your hypotenuse, 17ths. So 15/17, that's your ratio for sine. And last but not least, tangent. So your opposite, which is 15. Okay, your adjacent, -8. Okay, there isn't anything that 15 and -8 have in common, so you can leave it. I know it's an improper fraction, and there's a lot of teachers that are just unhinged by seeing it, but it's okay. Okay, you're gonna live. All right. So that is it. It's as simple as that. One, you have to know what quadrants your point's going to lie in. Once you figure that out, you draw a line from that point to the origin, creating your right triangle, bringing in your theta. Okay. So your partner can do most of the work, just creating that theta. And then take your time with figuring out the unknown side. Okay. So that is about it, guys. So this, and I'm thinking of like at least once a week, I'll come on here and just break down some concepts. So today we basically looked at trig functions using a point on that coordinate grid. And we'll see what other troubles that keeps coming up in my sessions. And we're going to take it from there. So speaking of sessions, now I do still have a couple positions left, just two really, for my online math tutoring. If you know someone that needs assistance, do not hesitate to reach out. Now, I also go live on TikTok, and I go live quite often over there. So I will be live tonight at 8:30. And I will actually be working on matrices. So 8:30 Eastern Standard Time, I'll be on TikTok. And what else is there for me? Oh, and if you want to, you can subscribe to my YouTube channel. Sorry about to sneeze again. This pollen's killing me. So Audrey Connor, ACG Math Tutoring. So I usually have like a lot of my replays of my YouTube lives are on there. Also some suggestions, some shorts that goes with factoring, that goes with absolute values, fractions, decimals, percents, scientific notation, function notation, you name it. If it's algebra, I am doing it. So at least you can get something to help you out for the rest of the year. But if you do need somebody, maybe your child is not going to pass this year and they're going to need some assistance during the summer to complete like summer projects or anything like that, just let me know. Just reach out. All right. So you guys have an amazing day. I will see you on the flip side. If you ever need any assistance whatsoever, please do not hesitate to reach out and message me. All right. Have an amazing day, guys. Take care. Bye now.